Hello and welcome to Tech of the Day. Today we are going to talk about implementing access control. What is access control? In this module, we will talk about claim-based authorization, role-based access control, virtual machine access control. So these are really small topics but very important, and I have already done another video on authentication in Azure. In that video I talked about Azure Active Directory and Azure development library for authentication using ADAL, MSAL. So I talked about a lot of stuff. It's a really long video, 1 hour 30, around 1.5 hours. You will find a lot of information in that video, but in this one I'm only going to talk about claim-based authorization, role-based access control, and virtual machine access control. If you want to know more about Azure Active Directory, watch my another previous video. So let's go. I have already talked about topics. We are going to discuss claim-based authorization, role-based access control, RBAC, virtual machine access control. Claim-based authorization. In this lesson, we will talk about claims and claim-based authorization. So, process of determining which entity have permission to change, view, or otherwise access a computer resource. So, what is claims authorization? Process of determining which entity have permission to change, view, or otherwise access a computer resource. It can be a user, it can be a resource, so it can be anything. Just determining if that particular entity has the permission. Example, in a corporate application, only managers can delete a customer record. So user, after authenticated, the user will request to delete a customer record. If the user is a manager, we can then authorize the user to delete it. Simple. Claims identity providers. So in this sample workflow, the user needs to access an application, so they first sign in by using their social identity. After they are signed in, the identity provider is trusted by the organization's application and can share claims about that user with the application. So you sign in with the third party or social identity providers. After you signed in, then you decide about the claims. You get the claims in return and you decide them. When it's very good example actually, driver's license, and it's not my idea, especially I took this example from internet, so bear in mind, I think you will find it somewhere. When an identity is created, it may be assigned one or more claims issued by a trusted party. A claim is name value pair that represents what the subject is and not what the subject can do. So claim is a key value pair. Claims a key value pair. Here, as you see, name is the claim name, and the value is Rocco M Yarborough, and then the claim name of the claim is date of birth, and that is this one, this one, this one. So it's not something roles, it's claims, it's key value pair. So there is difference between roles. We also there are many terms in use for authentication, and all of them are relevant and all of them have their own role. So there are like claims, principles, policy, roles. There are all different things. I have discussed these things in my another video for authentication and authorization, and that video you can find out in my playlist. If you go to my channel, you will find a playlist authentication and authorization, and in that playlist you will find that video. Okay, let's continue. So in this claim, the claim name would be date of birth. In the previous example, the claim value would be your date of birth. For example, January 8, 2020, and the issuer would be the authority who issued your identity or your license. This one who issued this identity. So if we compare this driver license example with our uh, authentication process, then the authority who provides this license is the third party social identity providers like Facebook, LinkedIn, Twitter, or whatever. And then the claims are the information that provider, that third party, gives us. An identity can contain multiple claims with multiple values and can contain multiple claims of the same type. And then uh, the claim was, let's say, for another example, the claim was issued by Contoso Motor Vehicle Agency. Trust but verify our authorities. We trust any information given to us by this agency. We will verify that claims did in fact come from this agency. Because we trust this agency, we can trust that values of the claims are true. So there is another thing, you don't trust all the identity providers, you only trust which you provide from your side to the user. Let's say you only uh, trust Facebook and LinkedIn. You don't trust Twitter, so you don't provide option to log in with Twitter, and you don't trust that. So you only trust specific providers. Claim based authorization. Instead of user belonging to specific groups, our claims will describe the user in more detail. We use the claims to determine if the user is authorized to perform a specific action. For example, if a user A attempts to go to secure section of our website, A is redirected to a list of identity providers, all the Facebook, LinkedIn, Twitter. User A sign in by using LinkedIn identity, let's say, and then user A gives LinkedIn permission to share data claims, which are actually the data is your claim, the claims with our application. Then user A is redirected to our website with a set of claims including name and email. And then we can store those claims in our local database in our application with the information that third party gave us, and we can decide with the unique information such as name or email and make that unique identity in our local system to recognize. And when second time the user try to log in with that ID, we already know who he is and what type of uh, his history we have in our system as well. So the term authentication and authorization, it is confusing. To keep it simple, authentication is act of verifying someone's identity. When you authenticate someone, you are determining who they are. Authorization is the act of verifying that someone has the access to a certain subsystem or operation. When you authorize someone, you are determining what they can do. So authentication is simply who are you, and authorization is what can you do. This I already explained this in my series authentication and authorization with .NET or .NET Core. Please watch that playlist in my channel. You will find it, and it's really informative. So authentication: user A attempts to go to the secure section of our website. User A is redirected to lists of identity providers as we did in this previous step, and then user A signs in with one of the identity providers, let's say Facebook, and Facebook uh, and user gives permission to Facebook to share his data with our application, and now our application has claims of that user, and then user is redirected to our website with those claims, and now our application reads user A's claims to determine if the user is authorized to perform certain actions. We might have a list of users email that are allowed to administrative access. So the email address we got from the third party identity provider, let's say Facebook gave us his name, date of birth and his email, then we will determine using his email if he is allowed to do certain actions or not. So claim based authorization, claim policy in ASP.NET. The simplest type of claim policy looks for the presence of a claim and it doesn't check the value. First, you need to build and register the policy. This takes place as part of authorization service configuration, which normally takes place in configure service in your startup.cs file, where you say add authorization with options add policy employee only, and the policy means what it require a claim employee number. But here you notice you created a policy, but you also say require a claim employee number, and now you need to create this claim also employee number, because in our system it's not known what does employee number claim means. So let's continue, and we use that policy. We just created employee only here. We use that policy in our for the authorization. Let's say if you just want to do some you just want to do some operation, then we verify if you are allowed or not with that policy employee only. So, and same way you say specific employees only with the employee ID, require claim employee ID and the values of that employee ID 12345. Okay, now we are going more detailed. So here we just said require claim employee number, so we just need in the claims the employee number only. So if Facebook gives us the employee number, or other identity provider gives us employee number, then we are happy. But now we also need employee ID with the value of 12345 only. So this is what you saw, just an example. Only specific employee IDs can succeed. I hope it's clear. Now let's go to the lesson 2, role based access control. Very interesting. In this lesson we will cover an overview of role-based access control, including Azure RBAC and role assignments, classic subscription administrator roles, Azure RBAC roles, and Azure Active Directory administrator roles. Managing access using RBAC and REST API, role-based authorization in ASP.NET. A lot of things to do. So, role-based access control overview. What is role-based access control? It's not specific to Azure. It's simple term. So before we said claim-based access. So user had certain claims. Then we gave the user access to certain specific services. Now we are checking the role of that user. So role is tied to that identity of that user. If that user has that role, then we allow access to certain services. So user permissions are managed and enforced by an application based on user's role. General access is assumed to be denied. If a user has a role that is required to perform an action, access is then granted. Identities can belong to one or more roles. So a single identity can have a admin role, configurer role, or other roles, custom roles you might have, and then they will perform actions accordingly. So they will have permissions uh, for all those roles they have. Let's say you have a role which allow you to read, so you have a reader role. Then you have another role, writer role. Then overall you have permissions to read and write both. Very simple. So in Azure role-based access control, role-based access control is not only tied to Azure, but as I said, but Azure also has that. It, so access management for cloud resource is critical function for any organization that is using the cloud. RBAC helps you manage who has access to Azure resources, what they can do with those resources, and what areas they have access to. RBAC is an authorization system built on Azure Resource Manager that provides fine-grained access management of Azure resources. So what it does, Azure RBAC provides fine-grained access management of resources in Azure. It's built on Azure Resource Manager. It segregates duty within your team, grant only amount of access to the users that they need to perform their jobs. This is RBAC in Azure. Concept. What are the concepts? So security principle, object that represents something that is requesting access to resource. Example, user group service principal managed identity. It can be anything. It's not only bound to users. So if your application can also have role-based access control to some resources. Role definition, collection of permissions. So simple. Role is simple, a collection of permissions that list the operations that can be performed with that role. So as I said already, example are reader, contributor, owner, admin, user access, administrator. You have many roles, and those roles contain certain permissions. Scope, boundary for the level of scope that is the access that is requested. So let's say scope is, let's say, for resource specific or management group specific, subscription or resource group specific. So scope can be that you have admin role on a specific resource, or you have admin role on a specific resource group, or on the subscription level. Assignment, attaching a role definition to a security principle at a particular scope. User can grant access described in a role definition by creating an assignment. Deny assignments are currently read-only and can only be set by Azure. So what is role definition? You have certain roles, let's say owner, contributor, reader, backup operator, security reader, and then in the role definition of the contributor, owner has its own definition, contributor has its own definition, and reader its own. So if we check the contributors definition, then you have actions, what it can do. Star means it can do everything. Not actions, so actions what you can do, not actions what you cannot do. So you can do everything, then you add except authorization, deleting everything. You don't have authorization to delete, you don't have authorization to write, and elevate access. You cannot access elevate, so you cannot elevate access. Data action. Note data actions assignables scope. So you see the definition. It's a JSON format. You can use this directly in your ARM template, but to create any role using .NET or SDK. And another information, these are built-in roles, predefined roles in Azure. You can also have custom roles which you create, like reader support tickets. It's a long name, but you create a specific custom roles according to your application requirements, so you can create them. Just you need to specify then what are the actions it can do, what are the actions it cannot do, all that thing. Role assignment. A role assignment is a process of attaching a role definition to a user, group, service principal, or managed identity at a particular scope for purpose of granting access. As you notice, I said attaching a role definition to a user, group, service principal, or managed identity. So it's not only user, it can be group, user group, or service principal, or managed identity. Access is granted by creating role assignment, and access is revoked by removing a role assignment. Point is, initially RBAC was an allow only model with no deny, but now RBAC supports deny assignments in a limited way. Similar to a role assignment, a deny assignment attaches a set of deny actions to a user, group, service principal, or managed identity at a particular scope for the purpose of denying access. So before we didn't have this option, but now we have denying access option. A role assignment defines a set of actions that are allowed, while a deny assignment defines a set of actions that are not allowed. In other words, deny assignment block users from performing specified actions, even if a role assignment grants them access. Deny assignments take precedence over role assignments. So they are, let's say you have, let's go back here. So here I said actions, star means all, but then the priority goes to not actions, and in not actions I said authorization to delete, all to delete. I don't have authorization, I cannot delete, so not action. That means not action will take priority and I don't have access to delete anything. A role assignment completes the process of implementing RBAC and combining service principles, a role definition, and a scope. Note that it is possible to create a role assignment by using the Azure portal, Azure CLI, Azure PowerShell, Azure SDK, or REST APIs. There is a limit of 2000 role assignments in each subscription. To create and remove role assignments, you must have Microsoft authorization / role assignments star permission. This permission is by default assigned to the owner or user access administrator roles. So only the owner and user access administrator role has that permission to assign any role. You have service principals, which are like user, group, and service principal. Then you have role assignments. It can say I want to assign this contributor role to this marketing group. Yeah, simple. With the scope of subscription, resource group, or specific to a resource. So I can say I want to set the scope to management group level. That means all the resources under this management group will have this role. Or in other words, let's say user is assigned a contributor role on this subscription. That means all the resources under this subscription, this user has that role. So in this demo, um, I will create a role-based assignment, role-based access control on a virtual machine. Let's go. And here, what I'm doing, I'm going to create a virtual machine, simple. And then that virtual machine, let me just create the virtual machine AZ-203, and what is the name? AZ-203 RBAC. Okay, and now virtual machine name is VM01. North Europe, I will go with default settings because it's not about virtual machine, and I'll go with username and password VM01 admin. I'll not tell you my password, but it's not that secure. Okay, SSH, I'm not going to check my options because I'm just going to create a simple virtual machine which validated. Now I can create. So I'm just creating a virtual machine, and then what I'm going to do, I'm going to create um, I'm going to add role in the access control, which is IAM. I'm going to create RBAC, role based access control assignment. I did this in my previous video, which is developing solutions that use virtual machine. And in that video, I also talked about a little bit giving access on that virtual machine using role-based access control. Okay, it's in process. Okay, it's done. Let me go to the resource now. Okay, up. So I need to go to the access control, and now simple in you see here already in this one I have the information about access role assignments, what role assignments I have. I don't have any role assignments yet. I didn't create any actually. And then deny assignments, I don't have any deny assignment. Okay, one more information. As I said, the limit is 2000, and you can have per subscription, you can have 2000 roles. You are allowed, your subscription allows you to add up to 2000 role assignments. Classic administrators, these are the default administrators. Then roles, owner, contributor, these are the built-in roles I was talking about. Monitoring, reader access control, Sarma, whatever you see. So what I'm going to do now, I'm going to add a role-based role assignment. You see here you have this add a role assignment. I'm going to create that. And what are the role assignment I want to give? Contributor, let's say. And then assign access to Azure Active Directory, user group or service principal. I can give access to this. I can give a user assigned managed identity. I can also give access, very interesting, to app service. I can give access to container instance. This is what I just discussed. You see, I discussed I can give access to app service, container instance, container registry task. I can give access to them. What type of access? What type of role? Contributor role. But here I'm going to give um, okay, I'm going to give this one. It will not find me. Okay, guest. Okay, it added me and save. So now I have my email. I have the access to this virtual machine. Okay, these are some important information. I am not going to show more. So that's how you can do it. Role-based access control overview from the Azure, what we just saw. So how RBAC determines if a user has access to a resource. A user or service principal acquires a token for Azure Resource Manager. The user makes a REST API call to Azure Resource Manager with the token attached, which we just got. The Azure Resource Manager retrieves the role in assignments and deny assignments that apply to the resource upon which the action is being taken. As I just added, then in this case that resource will be virtual machine I just created. Azure Resource Manager narrows the role assignments that apply to this user or their group and determines what roles the user has for this resource. Then Azure Resource Manager determines if the action in the API call is included in the roles that the user has for this resource. If the user doesn't have a role with the action at the requested scope, access is not granted. If the user has that role in that requested scope, then access is granted. If deny assignment applies, access is blocked. Otherwise, it's granted. Those who are new to Azure might find little bit challenging to understand the different roles in Azure. So you have classic subscription administrator roles, Azure role-based access control roles, Azure Active Directory administrator roles. There are three things you see, and it might be confusing. What is classic subscription administrator roles? As I just saw, Azure role-based access control roles, which we just added, and Azure Active Directory administrator roles, which we have to discuss. So to better understand roles in Microsoft Azure, it helps to know some of the history. When Azure was initially released, access to resources was managed with just three administrator roles: account administrator, service administrator, and co-administrator. Later, the role-based access control (RBAC) for Azure resources was added. The Azure RBAC is a newer authorization system that provides fine-grained access management to Azure resources. RBAC includes many built-in roles, can be assigned at different scopes, and allows you to create your own custom roles. To manage resources in Azure AD, such as groups, users, and domains, there are several Azure AD administrator roles. So you had the classic subscription administrator roles, which are service admin, co-admins, and then later on Azure added Azure RBAC roles, which you have inbuilt roles and custom roles you can have, and then you have roles based on your Azure Active Directory, which you are having automatically. So let's say I'm with my email address or with my identity, I have admin role. That means I don't have to always go to my virtual machine and add RBAC there. If I'm admin on somewhere on a subscription or somewhere, that means all the resources under that I am having that role. Azure RBAC is an authorization system built on Azure Resource Manager that provides fine-grained access management to Azure resource such as compute and resource storage. Azure RBAC includes more than 70 built-in roles, but there are four fundamental RBAC roles. The first three applies to the resource type, and the fourth one is user access administrator, which is providing access to a certain user. If we just want to talk about these roles, it's owner, contributor, reader, and user access administrator. Owner has full access to all the resources and can delegate access to others. Contributor creates and manages all the types of Azure resources but cannot grant access to others. Reader can view the Azure resources only. Azure RBAC roles versus Azure AD administrator roles. At high level, Azure RBAC roles control permissions to manage Azure resources, while Azure AD administrator roles control permissions to manage Azure Active Directory resources. That here you see the difference. Azure RBAC roles manage access to Azure resources, whereas Azure AD administrator roles manage access to Azure AD objects. Support custom roles. Azure RBAC roles support custom roles, and Azure AD does not support custom roles. Scope can be specified at multiple levels in a RBAC, but scope is at the tenant level. That's why we needed to add RBAC roles, as we already had Azure AD administrator roles. Role information can be accessed in Azure Portal, Azure CLI, Azure PowerShell, Azure Resource Manager template, or REST API. But in Azure AD, role information can be accessed in Azure Portal, Office 365, Admin Portal, Microsoft Graph, Azure Active Directory, PowerShell for Graph. But it cannot be accessed using your REST API. To manage role-based access control is the way that you manage access to resource in Azure. In this slide, I'm providing you the overview of how you manage your access to Azure users, groups, and applications by using RBAC and REST API. So here you see list access. In RBAC, to list access, you list the roles assignments. To list role assignments, you use one of the role assignment list REST APIs to refine your results. You specify a scope and optional filter. So you say get this with this scope. Provider is Microsoft Authorization. Role assignments with this, and filter is your filter. Same way you can grant access. In RBAC, to grant access, you create a role assignment. To create a role assignment, use the role assignment, create REST API, and specify the security principal, role definition, and scope. And to call this API, you must have access to the Microsoft Authorization role assignments write operation of the built-in roles. Only owner and user access administrators are granted access to this operation. So you should be owner actually of that resource. Use the role definition, and then after you have the role definition, you can create or grant access. So you have to use put management azure.com with that scope, read, write, or whatever. Provider is Microsoft Authorization role assignment, and the name of the custom role assignment, and this is simple API version with the properties role definition ID which you just created, and the subscription ID, role definition ID which you just created here. And same way you can remove an access using call to using method verb actually, sorry, delete verb, and calling this API with the assignment rule assignment name we just created here. Role based authorization in ASP.NET. Roles are exposed to the developer through the isInRole method on the claims principal class. Role-based authorization checks are declarative. The developer embeds them within their code against a controller or an action within a controller, specifying roles that the current user must be a member of to access the requested resource. So here you say authorize roles equals to administrator or power user, one of them, and then you say in the second in here you say this, but in the second action shut down you only allow it to administrator, but set time is allowed to power user as well. Same way, if you remember, I added the claims, and in the claim also here you said roles, but you can say claims and having those claims, so it's the same thing. Now to enforce roles by using policies in ASP.NET, role requirements can also be expressed by using policy syntax, where the developer registers a policy at a startup as part of the authorization service configuration. This normally occurs in configured service. Here you add the policy as we added same way in the same way for claim. We added the policy, and policy name is here we said require role, and there we said require claim administrator and power user. So you are authorized if you have these roles. Simple. Virtual machine access control. In this lesson, we will talk about virtual machine security exposure, authentication by using Azure AD, just-in-time access, and managed identity. Virtual machine security exposure. Secure identity. It prevents user from creating new identity and passwords per VM. Secure ports. It prevents users from exposing ports longer than needed. Secure access prevents users from giving virtual machines too much power. So these are three exposures, virtual machine security exposures, which are there by default. Virtual machine authentication by using Azure AD. To improve the security of Linux virtual machines in Azure, you can integrate with the Azure AD authentication. When you use Azure AD authentication for Linux VM, you centrally control and enforce policies that allow or deny access to the VMs. The benefit of using Azure AD credentials to sign in to the Azure Linux VM, you don't have to create local administrator accounts and manage credential lifetimes. By reducing your reliance on local administrator accounts, you don't have to worry about issues such as credential loss or theft and users configuring weak credentials. So if you are based on let's say I just created the virtual machine which I gave a username and password which I can forget or I can give it to someone, but if I use Azure AD for that authentication, then I don't have to worry about these things. To further secure signing into Azure virtual machines, you can configure multi-factor authentication also. The ability to sign into Linux VMs with Azure Active Directory is also available for customers that use federation. Seamless collaboration with RBAC, you can specify who can sign into the given virtual machine as a regular user or as administrator. When users join or leave your team, you can update the RBAC policy for the VM to grant or remove access. This experience is much similar than having a scrub VMs to remove unnecessary secure shell, SSH, or public keys, because virtual machines you can also access virtual machines using SSH, secure shell keys, and if you want to remove access to some users, then you have to remove those SSH so that they cannot access. But you might have given those SSH keys to other users as well, so you are revoking access to everyone. Just-in-time access, JIT. You can use just-in-time access, VM access, to lock down inbound traffic to your Azure virtual machines, which reduce exposure to attacks and allows you to connect to VMs when needed. One way of reduce exposure to brute force attacks is to limit the amount of time that a port is open. Management ports don't always need to be open. They need to be open only when you are connected to a VM, for example, to perform management or maintenance tasks. So you don't allow management ports to be open all the time. When a user requests access to VM, Azure Security Center checks if the user has RBAC permissions that permit them to successfully request access to that VM. If the request is approved, Security Center automatically configures the network security groups (NSGs) and firewall to allow inbound traffic to select ports and requested source IP addresses or ranges for the specified time. After that time expires, Security Center restores the NSGs to their previous states. However, Security Center won't interrupt established connections. So if you have already established connections, it won't be tempered, but you won't be allowed for the new connections. Same way, managed identities. So managed identities are service principals that you assign to Azure service. Azure AD automatically manages these identities. You can use a managed identity to authenticate any service that supports Azure AD authentication, including Key Vault, without adding any credential in your code. So internally managed identity are service principals for a special type that are locked to be used with Azure resources. When you delete a managed identity, the corresponding service principal is automatically removed. Your code can use a managed identity to request access token for services that support Azure AD authentication. Azure manages rolling the credentials that are used by service instance. So you can create managed identity. Let's say for you want to allow your app service to use Azure virtual machine or Azure storage. You create managed identity for your app service and you add that on the Azure storage. So Azure storage will have you will add that managed identity in role-based access control, that managed identity, and then your Azure app service can use that Azure storage without having any um, external code written in your app service. To assign, there are two types of managed identity. You have system assigned, user assigned. You enable a system assigned managed identity directly on Azure service instance. When you enable when you enable the identity, Azure creates an identity for the instance in the Azure AD tenant that is trusted by the subscription of the instance. After Azure creates the identity, it provides the credentials to the instance. The lifecycle of the system assigned identity is directly tied to the Azure service instance that it's enabled on. If you delete the instance, the Azure automatically cleans up the credentials and identities in Azure AD. Same way, you can create Azure assigned managed identity user assigned a managed identity as a standalone Azure resources. Through a create process, Azure creates an identity in the Azure AD tenant that's trusted by the subscription in use, same as system assigned managed identity. After Azure creates the identity, it can be assigned to one or more Azure service instances. The lifecycle of the user assigned identity is managed separately from the lifecycle of the Azure service instances to which it's assigned. So, system assigned key differences are it is enabled directly on Azure's resource, whereas Azure assigned is standalone resource. Azure creates and manages the identity, and user assigned can be assigned to one or more Azure resources. A system assigned automatically deleted when the resource is deleted, and for the user assigned, it's separate life cycle from assigned Azure resources. Managed identities for virtual machine using Azure PowerShell. A user assigned identity is created as a standalone Azure resource. By using the new Azure user assigned identity, user creates an identity in your Azure AD tenant that can be assigned to one or more Azure service instances. So you just created here. Here you say resource group name, my resource group VM, and name of the ID, name of the user assigned identity, ID1. And then you get the virtual machine's property, and then you assign the identity to that virtual machine. User assigned ID, identity ID, subscription, blah blah, all those information. A user assigned identity, same way you can do using Azure CLI, and you use AZ identity create. Here we used new AZ user assigned identity, but here we use AZ identity create. It's a similar, but the syntax is different, and Azure CLI and Azure PowerShell, so that's the only difference in, but you do the same thing. So review. In this video, we talked about claim-based authorization, role-based access control authorization, and virtual machine access control. I hope you liked it, and please like, share, and subscribe. And thanks for watching. If you want to watch my other videos related to authentication and authorization, then you can find the playlist in my channel. Or if you want to watch other videos related to Azure AZ-203 or AZ-204 certification related videos, then you can watch them in my playlist as well in my channel. Thanks for watching. See you.